Today I am going to solve one chemical reaction engineering problem. So that problem requires the knowledge of numerical method in chemical engineering. Now here is the problem. The chemical reaction often follows the model. So that is minus dCA by dt is equal to K C to the power n, where C is the concentration, T is time, K is reaction rate and N is reaction order. Use the following data. Find the value of K and N. Now here the model is given minus dC by dt is equal to K C to the power n, and the datas are given. T data, T is equal to 10, 20, 30, 40, 50, 60, and C is given, means concentration is given. Concentration is 3.52, 2.48, 1.75, 1.23, 0.87 and 0.61. That is that data are given. Now here we have to find out what will be the value of K, means reaction rate and order of the reaction. So that we have to find out. Now first, how do you solve this problem? Okay, now here that chemical reaction is dC by dt is equal to minus K C to the power n, or we can write minus dC by dt is equal to K C to the power n. Now taking both side the ln log, if I take log in both side, so ln minus dC by dt is equal to ln K plus n ln C. So now we can write this whole equation as a y is equal to mx plus c. So if we write that this is y, this is x, this is m, and this is c. So y is equal to c plus mx or mx plus c. Now y is equal to nothing but ln minus dCA by dt, x is equal to ln c, n is equal to nothing but m, means slope, and c is intercept. So here I am putting a red color, that is denote as a intercept. So that is equal to ln k. Now if we plot ln c versus ln minus dC by dt, so then we get the straight line, and from the straight line we can easily get the slope and intercept. Now so first we have so t versus c data are given, correct? So now here plot is like here plot is ln c versus ln minus dC by dt. Now first we have to find out dC by dt. Now how do you find out dC by dt? Now here we need numerical technique. We will use numerical technique here. Now here you can see the t datas and c datas are given. Now here we will use central difference except for the extreme point, for which we can use forward and backward difference. Now for this data, so we have to find out dCA by dt. Okay, means we ultimately have to find out ln minus dCA by dt. Okay, so for first data we can use forward difference, and last data we will use backward difference, and in the meantime, means in the middle of the data 20, 30, 40, 50, we will use central difference. Now here for central difference for 20, 30, 40 and 50, so we know central difference dCA by dt is equal to c t to the power n plus 1 minus c t to the power n minus 1 by t to the power n plus 1 minus t to the power n minus 1. So based on that we can get the dCA by dt. So here if we want to calculate this dCA by dt this point, so we have to take this value minus this value divided by this value by this value. So here, so 1.75 minus 3.52 by 30 minus 10. So we'll get, if we do the calculation, we'll get minus 0.0885. Similarly, for dC by dt as t is equal to 30, so this point, if we want to calculate, so this value minus this value divided by 40 minus 20. So we can easily get, that is minus 0.0625. Similarly, we can calculate dCA by dt at t is equal to 40. So this, so we have to take this data and this data, 0.87 minus 1.75 divided by 50 minus 30. So minus 0.044, and then t is equal to 50. So we can take this data and this data. So that is 0.61 minus 1.23, 60 minus 40, that is minus 0.031. And then forward difference at t is equal to 0. So this point we have to take the forward difference. Forward difference means this value minus this value, 20 minus 10. So 2.48 minus 3.52, 20 minus 10, so that is minus 0.104. And backward difference at t is equal to 60, so that is ctn minus ctn minus 1, tn minus tn minus 1. So this is that ctn is 0.61 minus this value 0.87 by 60 minus 50. So this is backward difference. So we know all dca by dt value. Now in that in the table you can see, so this is t, this is dca by dt, so we got all this value. Now minus dca by dt we have to take that. So minus dca by dt, we just minus will be removed, so 0.104 something like that. Then now we know, so when we took the log, so that is ln minus dca by dt is equal to ln k plus n ln c. So now we have to find out ln minus dca by dt. Now in this table you can see that I did the calculation in that excel. So here ln dca by dt, so that is minus 2.26336. Then this is this point, this is 0.0885, and then 0.0625, 0.04, that is minus 3.12357. so we did that, we got that ln dc minus dc by dt. And also we need ln c, so here ln c we need. Okay, so ln c, that is natural log of 3.52, we will get this value. Now if we plot ln c versus ln d minus dc by dt, so we will get that. So log c, not log, so that is ln c, and this is also ln. Okay, ln minus dca by dt. Now we will get this point, and if we take the trend line, okay, so we will get the equation. So that equation is 0.8506 x minus 3.2773. so that is nothing but, so minus ln ln minus dca by dt, okay, is equal to n ln c then plus ln k. So n is nothing but 0.8506. so that is the order of the equation. It is nearly equal to, we can say 1, or sometime it is a polymerization reactant polymerization reaction, so that n can be in the fraction. Okay, so n is equal to 0.8506, and that intercept, so that is minus 3.2773. so that is ln k. ln k is equal to minus 3.2773. so that k will be, if we take that ln k is this, k will be e to the power minus of 3.2773. from that we can easily get the k, so that is k value is this 0.03773. so now that k and order of the reaction, so that is n 0.8506. so we got that two value. So in that question they are asking, use the following data to find the value of k and n. So n is equal to 0.85 and k is equal to 0.8506 and k is equal to 0.03773. That's it. Thank you.